Welcome! Let's take a journey into the heart of seismic transducers. Today, we will embark on a didactic adventure with none other than Alex Groth, Corey Lissy, and
Alec Albergo.
thank you for tuning in. Let's begin!
What is a seismic transducer? A seismic transducer measures small movements in the ground. It amplifies and records all these movements for them to be observed and the data to be analyzed. A few other names for a seismic transducer would be a seismometer or a seismic sensor. Some examples of the measurements that a seismic transducer would take would be of earthquakes, volcanic eruptions, and other vibrations that a scientist or engineer would wish to measure. Seismic transducers can be used to detect and record vibrations in many things, such as bearing supports, the resonances of foundations, turbines or compressors, and gears, and any other things that you would wish to measure vibrations or certain oscillations in. These transducers are not only used to measure/record vibrations where they're expected, but also can be used to measure vibrations in a system that optimally should have none. So this can overall prevent the failure of certain devices or designs that an engineer would have.
How does it work? Well, there are two basic types of seismic transducers. There are inertial seismometers and strain meters, or otherwise known as extensometers. Inertial seismometers measure ground motion relative to an inertial reference, and strain meters or extensometers measure the motion of one point of the ground relative to another.
First type is the inertial seismometer. It consists of a weight, shown here, suspended from a frame by springs. There are two in this case. Now the frame moves due to the vibration being measured, but the mass is held stationary due to these springs. As you can see here, the frame is held to the whatever you are measuring, so that would be moving with the vibrations, but the springs hold the mass stationary. It is generally used on larger scale vibrations such as earthquakes. Now the movement of the mass is transduced and outputted as a voltage or an electrical signal right there.
And here's an example of a strain meter seismic transducer. Strain gauges, or meters, are used to measure motion relative to another point. They're generally used for smaller scale measurements such as gears. Like the previous seismic transducer, the measurement of the system is generally outputted as a digital signal.
Since both of these types of seismic transducers are most commonly outputted as an electrical signal or voltage, calibration is necessary. The calibration is used to link the input and output, the input being the motion of the mass and the output being the voltage. There are two steps in calibrating all seismic transducers. The first step being exciting the seismic mass with an electromagnetic force. A lot of newer transducers now have a built-in calibration coil which helps with this step. The next step requires mechanical test equipment. A lot of times they use a shake table, which you'll see in the next slide, and that is used as the standard for this calibration. This is a picture of the shake table. The seismic transducer would go on here, and the shake table would have a known movement, and it is used as the standard to calibrate seismic transducers. With all measurement systems, quality and accuracy is very important. Seismic transducers use an analog to digital converter that can be equipped to help with filtering to allow the desired signals through. The analog to digital converter, or ADC, uses a low-pass filter to remove all signals that don't follow the Nyquist criteria, which we learned about in class. This is crucial to avoid aliasing. In this way, the ADC works as an anti-aliasing filter. One way to decrease the uncertainty is to sample at a much higher rate than required, which also increases the resolution of the instrument. Every measurement system has some sort of error. When it comes to the seismic transducer, there are three main sources of error: noise, drift, and nonlinear distortions. Thank you for coming along on that fun journey learning about seismic transducers. Here are all the sources that we used for our slides and information today. If you would love to look at them and learn more.